right, in this video we're going to look at your quiz from sections 11.1 to 11.3. So again, the order that my quiz will look will probably be different from yours. So let's go ahead and start with this first one as soon as it loads up here. Okay, so for this one, I'm going to use that sheet. Okay, so remember online you should have had that standard normal distribution table. You could use your table or you can use your calculator, but for some of these, using your table is going to be just as easy as using the calculator. Especially this one, because this one we're just looking to see what values are to the left of 1.37, and that's the way that our table is set up for us. Now I don't have the table in front of us here, but you can look at it on your own. But if you look at 1.37, looking at mine here, we get 0.9147 is what the area to the left of that would be. So 0.9147 would be your answer for that one there. All right, so let's look at what comes next. So here's the similar one. Now this one I'm going to use my table as well. I'm just going to sketch it here so you can see what I'm talking about. Okay, so we're trying to find that shaded region, which is there we go, 0.85. Negative 0.85. So we don't have negative values, remember, on our table. But what we can do is, if we look at that, so that's, if we look at the table for positive 0.85, and found that shaded area is going to be the same as the area over here. Okay, so hopefully you guys recognize that. So if I look at the table at 0.85, I get 0.8023. So this area here is 0.8023. So that means this is also 0.8023. But that's not what we want. Okay, we want the area of this blue shaded region. So to find that, I'm going to take, remember what's underneath that, the area under the line is 1. So if we want to find the leftover piece, I would take 1 minus 0.8023. And when I do that, I get 0.1977. So 0.1977 would be the area of that blue shaded region. So that's what we put in here. 0.1977. All right, so this is just setting up a normal curve. And so it says a recent study was done. It was found that the average age for people who buy their first car is 53 with a standard deviation of 3 years. Add the normal curve below with the values of the x-axis. Okay, so we're not converting these to z-scores. We're just using just the value. We know that d, so d is our middle term here. So d is going to be where the mean is. Okay, so it says the average age for when they buy the new car is 53. And by the way, I looked this up. This is all a true statement here. So that is the case, that the average age is 53. I'm buying a brand new car. But anyways, the standard deviation is 3 years. So that means if we're going to go to the right of d, then every one of these marks we're going to increase by 3. Basically, that's what our scale is going to be. We're going to count by 3. So if I wanted to go to the left, I would subtract 3. So 53 minus 3 would be 50. And then this would be 47. And then A would be 44. And to the right of our mean, or 53, we're going to add 3. And so we would have 56. 56. And then we would have 59. And then we would have 62. All right, so here's another one. Now we could use our table for this, or you could use your calculator. Now to be honest, this one here would be easier to use. Use your cursor out of the way. It'd be easier to use your table on this one. I'll show you how to use your calculator on a different one though, but I'll show you how to use your table. So this one we have between 1.82 and negative 1.82. So we're trying to find the shaded region in between there. Now our table is going to give us the area to the left of 1.82. So I'm going to look that up. So on my table here, I'm looking at 1.82 would be 0.9656. But what we want to do is that includes everything. That includes this area here. And we don't want to include that area. So we want to remove that from the 0.9656. So I got to figure out, well, what would that be? Well, if you notice, this area here and this area are the same. So from the left of 1.82, if that's 0.9656, and if everything under the line is 1, to figure out what this piece is, I would take 1 minus 0.9656. When you do that, you get 0.0344. And so this piece is 0.0344. That means this piece over here is the same, 0.0344. And I don't want to include that with that blue shaded region. We want to remove it. Okay, so I'm going to take that 0.9656, because remember, let me erase this here. That 0.9656 represents all of that, okay, even all the way down to 0. And we only want to include just this, oops, let me shade that to blue. Just this region here is what we want. So we want to remove this piece. So to do that, I would just take and subtract 0.0344 from 0.9656. And when you do that, we get 0.9312. So the area of this shaded region would be 0.9312. Because again, if we were to add that to the 0.0344, we'd get to 0.9656. Let's put in, so our answer, 0.9312. All right, so here, oops, there we go. So here it says, find the mean when the value x is 29 and the standard deviation of 2 and a z-score of 1.75. Okay, so the value of x, when the value of x is 29 and has a standard deviation of 2 and a z-score of 1.75. So remember, to find a z-score, we take the value for x minus the mean and divide it by the standard deviation. So we're trying to find the mean when the value for x is 29, so we'd have 29 minus the mean, which is what we're trying to find, and the standard deviation of 2, and a z-score of 1.75. So I'm going to solve this equation, so I'm going to start that by multiplying. I want to get rid of the fraction, so I'm going to multiply both sides by 2. So on the left side, I'm going to take 1.75 times 2, and when we do that, we get 3.5. Oops. So we get 3.5 equals 29 minus x, x bar. So now what I could do is I could subtract 29 from both sides. Now when you do that, you might think, oh my goodness, what's going on? I get a negative number. We can't have that. You're right, we can have that. But what we have is negative 25.5 equals the negative mean. And so remember in algebra, if we have that, we can just multiply both sides by a negative. So that means the mean would be 25.5. All right, so let's look at this one here. So this is another one of those where you could use your table or you could use your calculator. I'm going to show you again how to use your table. So for this one, we want to find the right of what's to the right of negative 1.05. Okay, so we want to find the area of this shaded region. Well, again, our table does not do negatives. Our table only does positives. And so if we were to flip that around and put, 1.05 over here, if I could ever erase this, there we go. So to the left of 1.05 and to the right of negative 1.05, those are the same shaded regions. That is the same area. And so all I have to do is look on my table now, find 1.05 in my table. And when we do that, 1.05 is 0.8531. So if that area is 0.5 or 0.8531, this area is also going to be 0.8531 because they're the same thing, just a mirror image. All right, so this one, we're just finding the z-score. So we already talked about how to find the z-score a minute ago. So to find the z-score, we're going to take the x value. So the x value is 75. The mean is 32. So you want to make sure you do that in the right order. Don't just be absent-minded here. Standard deviation, by the way, is 24. But don't be absent-minded and just take the first x you see and subtract it from the second x you see. It's always the value for x minus the mean. So it would be 75 minus 32 is what we would have in the numerator. And 75 minus 32 is 43. And then we would take 43 divided by 24. When you do that, we get 1.79. Now it says to round to the nearest hundredths place, so that's just 2 numbers past the decimal. So round that to 1.79. All right, so this one here, this is a good story problem. It says, a recent study by the Edina Police Department found that the average speed outside the high school on Valley View Road is 37 miles per hour with a standard deviation of 2 miles per hour. And maybe help you to draw your own normal curve before answering the questions. I'm not going to take the time to do that. But it says, about what percent of cars are traveling faster than 29 miles per hour? Well, if the speed limit, if the average is 37, so the 37 would go right in the middle, and the standard deviation is 2, so that means our scale would count by 2. So 37 plus 2 would be 39. So after the 68%, so that first pink and the red is what we would add together. And so that would be, the pink there would represent 13.5%, the red would represent 2.5%. So if you add those together, we would get 16%. So we would expect, that's in the percent sign's already there, but we would expect that there'd be 16% of the cars traveling faster than 29 miles per hour. Now, if the speed limit is 35 miles per hour and during school hours 400 cars travel this stretch of road, approximately how many cars would you expect to go faster than the speed limit? And so to figure that out, we're going to take well, first we got to figure out, well, what percent of cars is that? Okay, so we know that there's 400 cars. But this, if the speed limit is 35, we want to figure out approximately how many cars we expect to go faster than the speed limit. So what we're going to have to do there is, so we have the 68, so 35 miles per hour. So remember, the mean would be 37. So 35 would be the edge of that 68%. So we would take 68%, because that purple middle section would be above 35 miles per hour, and the pink and the red. We'd add all those together. So 68%. The second pink there of the 13.5% plus the red of the 2.5%. When you add those together, we get 84%, which as a decimal is 0.84. So that means 84% of the cars travel faster than the speed limit. So if you take 0.84 times 400, we would get 336 as your answer. So that was a tricky one, that second part there, 336. Of the cars, 336 of the 400 cars would be traveling faster than the speed limit. All right, let's go to number 9. It says a reaction time in a particular psychological experiment is measured by how quickly a participant presses a spacebar on a keyboard. Historically, the experiment has been normally distributed with a mean reaction time of 0.43 seconds and a standard deviation of 0.25 seconds. We want to find the percent of participants who you'd expect to take less than 0.5 seconds to respond. Okay, so the first thing I got to do is I got to convert that 0.5 seconds to a z-score, because then I can either use my table or we can use our calculators. And for this one, we'll just use our calculators. So to find the z-score, we're going to find, first off, again, a z-score for the 0.5. So we take 0.5 minus the average speed, which is 0.43, divided by the standard deviation, which was 0.25. When we do that, we get 0.28. So that's our z-score is 0.28. And so we want to figure out the percent of participants we would expect to take less than 0.5 seconds to respond. So on our calculators, you can see here I've already done a normal distribution, so I'm just going to do this again. So what we're going to do is we're going to hit the catalog button to get to that normal CDF. And then, again, we want everything to the left of that negative, or that 0.28. So I'm going to say, now, some of your calculators might be able to do negative infinity. I don't think mine does, so I'm just going to type it in, though, and we'll see. So we'll do, oops, not, to do a negative sign. Make sure you use a negative symbol, not the minus sign. There we go. And then, so from negative infinity up to 0.28. We're trying to find that area. And then we always end with 0 and 1. Yeah, that's what I thought. It's going to give me an error. For some of your calculators, that's not going to be the case. So let's just use a really small negative number, like we could use negative 10. And when you do that, we get a decimal 0.61026. If you're wondering, well, how would I know to use 10? I talked about this in the video, but even if we used a number like negative 7, notice how we get the same answer. I could use negative 700. Or let's even do 7,000. we get the same answer. So as long as you use a smaller number than like -3, I would say you would be fine. But anyhow, 0.61, if we round that to the nearest percent without a decimal, we would round that to 61%. All right, so this one, it says, a conservatory agency reports that American bald eagle's wingspan is normally distributed with a mean of 82 and a standard deviation of 4 inches. If an American bald eagle is chosen at random, what is the probability that the wingspan is greater than 92 inches? Okay, so first off, with that piece of information, we're going to find the z-score for that value. So we're going to find the z-score for a wingspan of 92 inches. So we're going to have 92 minus the mean, which is 82, divided by the standard deviation, which is 4. So 92 minus 82 is obviously 10, and 10 divided by 4 would be 2.5. So we're dealing with 2.5. Now it's saying, what is the probability that the wingspan is greater than 92 inches? So again, that 92 inches would be 2.5 standard deviations above the mean. So we're looking at this. So 2.5 would be right there. So we're looking at greater than 2.5%. So that little sliver. So it's going to be a small amount. So the way that you're going to do that is, let's do this on our calculator again. Where's my calculator at? Here we go. So I'm going to do that bookmark again. So once you're there, the nice thing about this calculator is it goes right back to it. So our smallest value in this case is, our z-score is 2.5. And again, I'm just going to use a large number, like you could use 9, you could use 10, and then 0 and 1. And when we change this to a percent, it says do not change to a percent, but round to 4 numbers past the decimal if necessary. So if rounding 4 numbers past the decimal would be 0.0062. So we're not doing percents here. The eagle has a wingspan between, so we're going to find the probability that the eagle has a wingspan between 74 and 83 inches. So now we're going to need 2 z-scores for this one. We need to convert that 74 to a z-score and the 83 to a z-score. So the z-score for, let's start with the 74. So you take 74 minus the mean, which is 82, divided by the standard deviation, which is 4. And when you do that, you end up getting -2 is your z-score. Because 74 minus 82 would be -8, divided by 4 is -2. So now let's find our z-score for the 83. So again, you always have to find the z-score for these if you're going to use your calculator or the table. And so for this one, 83 minus 82 would be just 1, and 1 divided by 4 would be 1/4, which we'll just look at 0.25. So here's what's going on for this one. So we're trying to find the probability that's going to be between -2, say that's 0, and 0.25. Okay, so we're trying to find the area of this shaded region. So that's the limits that I'm going to use on my calculator. So I'm going to go to our calculator. I'm going to do that bookmark. CDF again. And so we would have our lower limit was, what was it? It was -2. Oops. -2. And then our upper limit was 0.25. And then 0 and 1. When we do that, we get 0.5759. And then after that is a 5. So we would round this up to 6. So it'll be 0.5760. 0.5760. Or if you said 0.576, that'd be fine. You wouldn't want to leave it as 0.5759 because after the 9 is a 5, and so with rounding, we'd want to round that up to the next closest number, which is actually going from 59 to 60. So 60 is the last 2 digits there. All right, last question, number 11. It says, what percent of data is between, it says answer the following questions based on a normal distribution curve. Do not include the percent sign in your answers. Notice it is already provided. So this one you can see, since my screen is smaller here, the percent got bumped down to the next row. But here it's saying what percent of data is between 0 and 1 standard deviations above the mean. So it's just a matter of looking at your notes. And so you'd get 34% there. What percent of data is between 1 and 2 standard deviations above the mean? That would be 13.5. And what percent of data is more than 2 standard deviations above the mean? That would be 2.5%. So that's how you do that last question. So hopefully that answers the questions that you got wrong on your quiz. And just like I've said before, if you do have any questions on these, please make sure you reach out to me, and I'd be happy to sit and work with you and help you figure out what you did wrong.